Section 5.2, we are going to do our last section of new material, and this section is systems of linear equations, but instead of having two variables like we did last time, we're going to have three variables. So we are going to have systems that look something like this: three equations, three variables, and the first, it's going to feel a lot like our last section of material because a lot of our methods are going to be the same. They're just going to be sort of an expanded view. So if it asks me if negative 2, 5, 3 is a solution to the system, how would I answer that question? What would I do? Yeah, we're going to substitute it in. We just substituted it into three locations instead of two. So for the first equation, I have negative 2, let me use white, negative 2 plus 5 minus, and then it's a 3. Equals 0. So this is my first equation. Let me actually number my equations so that we keep track of them. This is equation number 1, equation 2, and equation 3. The numbering will become more useful, even more helpful later on. So if we take negative 2 plus 5 minus 3, will that in fact equal 0? Yeah, it does. This one checks out. So it works for the first equation. So we'll go on to the second one. If it fails at any point, we can stop. We know the answer is no. But it worked for the first one, so we'll move on to the second one. The second equation is 3, so I have 3 times negative 2 minus my 5, and then plus 3 times, what was my other number, 3. And I'm trying to see if that equals negative 2. All right, so this one's got a little multiplication, so I've got negative 6 minus 5 plus 9. Negative 6 minus 5 is negative 11, and negative 11 plus 9 is negative 2, so we're good on that one. Equation number 3, I have x, so negative 2, plus 2 times y, which is 5, minus 3 times z, which I'm saying is 3. We want to know if that equals negative 1. So negative 2, 5 times 2 is 10, and then negative 3 times 3 is negative 9. Negative 2 plus 10 is 8. 8 minus 9, negative 1. So is this a solution? Yes, it worked in all three. So yeah, it's a solution. All right, so what were the three methods we had when we solved systems, though? Not just for checking them, but we solved them last time. Graphing, substitution, and elimination. All right, let's talk about those three options and why we will very quickly only have one option here. There's other options, but just not one of those three. Graphing would require us to be able to graph in 3 dimensions. It's a problem, right? Your calculator won't do that for us. It won't graph in 3 dimensions. So there are devices that do that, but we don't have them readily at our disposal. So graphing is not going to be a good choice. Substitution. Substitution required us to solve one equation for one variable. And the problem is all my equations have 3 variables, so I wouldn't be able to eliminate and solve one equation in terms of the other variable. That's like not a possibility, right? So our option right here that we're going to move into, the only option left that we've explored before, is elimination or addition method. That's actually what we're going to be doing. Let me make one comment before you start writing. There are other methods. In particular, there's a method called matrices. Perhaps you saw something with them in high school, maybe not. But matrices is another really nice way to solve this problem. I just don't have time to teach you everything. So we're going to stick with the elimination method because it's most closely related to the other one we've already seen. So our method's going to be using the addition or subtraction to eliminate the same variable from 2 pairs of the original equation. So when we worked with elimination last time, what we tried to do is to get one of our coefficients to match, but opposite signs, right? We're going to do the same thing here. We're going to select 2 equations, try to get one coefficient pair to match. Maxwell.
It says use addition or substitution.
Yeah, we're going to use addition. Technically, you can use substitution. It's really messy, though. Okay. If we have an equation where it doesn't have all 3 variables, we might choose to use substitution. We don't have any of those in my notes because I wanted to do things that were most general. But if you had an equation, if you had one like this, where you actually had one of them, like let's say the first one, instead of saying this, actually just said y minus z equals 0. Well, that would be okay to solve for one equation in terms of one variable. But when I have 3 equations present in all 3 variables present in all 3 equations, it's not a very good option. After we have eliminated one of the variables out of all three equations, we will solve the remaining two equations just like we did in the last section. And then again, we will back substitute to find, in this case, our third variable. And we really should check to make sure that it works. There's a lot that can, that's not even true to say it that way. It's just easy to make a mistake because we have a lot of steps. That's really an accurate statement. So since we have so many steps in these problems, it's a good thing when we're done to make sure that it actually worked. Something else to sort of keep in mind is just like last time, if you're getting answers that seem pretty weird, you might have made a mistake. They're creating these equations on purpose to have fairly nice integer value or maybe easy fraction value like 1/2 values. So if you're getting weird things like 11/32, there's probably a mistake that's been made somewhere, all right? So use that as a rule of thumb as you're working. All right, you guys ready to try an example? We've got lots of examples. That's really all that's pretty much left in our lesson today is just examples. Okay, so here's an equation, a system of equations. You'll have to take a second to write down, of course. 3 equations, 3 unknowns in all, 3 unknowns in all of the 3 equations. And what we do have to decide at the very beginning is which coefficients it looks like are going to be the easiest to eliminate. So sometimes you have more than one choice that seem pretty nice. Sometimes they all look equally, nice or not nice or whatever. I think this one has options in any of the options that will be okay. So let's decide. Do you want to eliminate x's, y's, or z's? X. Okay, thanks for making a choice for us. Appreciate it. All right, so if I want to eliminate x, the easiest thing to do is to take this equation at the bottom and to group it with one of the two at the top. And the reason is because that x has a linear coefficient of 1, right? The leading coefficient of 1. And if you compare it to the 3 or the 4, I can change it into 3 or 4 pretty easily. Does that make sense? Okay, so I'm going to label these as 1, 2, and 3 so that we can keep track of them as well. So I'm going to take equation number 1, rewritten exactly like it is. So 4x minus 2y plus z equals 13. But I want to take equation 3 and I want to actually multiply it by something to eliminate the x. What would it be multiplied by for that to happen? 4. And it's negative, you're right. So negative 4. So we're going to multiply all of equation 3 by negative 4. So this is still equation 3, but it's going to be adjusted. So I have negative 4x minus 12y plus 12z equals positive 40. Okay, y'all good? And we're going to add down. Now, again, the whole point is that when I add down the first two, the x's eliminate. So what do I have left? Well, I have negative 14y, positive 13z, and 53. Okay, everybody good? Okay, we're going to come back to this equation in a moment, but we're going to call it equation 4, all right? Okay, everybody still good? All right, the equation I didn't take, sorry, Maxwell, I will.
Really slow. I'm so sorry. Okay, you can go.
Okay, the equation that I didn't take, I have to use it now because it's got to obviously be involved if I'm going to find out a solution to all 3. So I need equation 2, and I can group equation 2 either with equation 1 or with equation 3. Which one's going to be easier to eliminate the x in? Grouping it with equation 1, so 1 and 2, or 2 and 3? 2 and 3. And 2 will stay exactly like it is as well. So I have 3x minus y plus 2z equals 13. But over here now, I don't want to multiply equation 3 by negative 4. What would I need to multiply it by? Yeah, negative 3. So we're going to multiply equation 3 by negative 3. So I have negative 3x minus 9y and plus 9z equals negative 90. No, what was it? Sorry, I'm looking back and forth between my stuff. Negative, positive 30. Positive 30, yeah? Okay, positive 30. I was trying not to zoom in and zoom out on my screen very much, and I was confusing myself. Okay, did I get all my signs right? Negative, negative, positive, and then positive, so I think so. Signs will just kill you here. Because if you make a sign error at the very beginning and you don't catch it till the very end, you got to rework everything. Like everything. Okay? All right. Very good. My x is eliminated. That's the goal. So now what do I have? Okay, and we will give this the name equation 5. All right, the first sets of equations that we just did were very friendly. Equations 4 and 5 are not friendly. Can you tell me why I could say that? Those numbers are awful. There's no coefficients of 1. None of the numbers match or are even close, right? They really aren't. So I'm going to shift this work over here to the left and make it a little bit smaller. I don't want to get rid of it because we might need it as a reference point. We don't need it at the moment. So equation 4 was negative 14y plus 13z equals 53. And equation 5 is negative 10y plus 11z equals 43. All right, so since they don't have really anything in common, it doesn't necessarily matter which one we eliminate, but we're going to basically try to multiply them to get the same coefficient still. I'm going to suggest we go ahead and do that with the z's, and the reason is because you'll notice the y's have something in common, right? They both have a 2 in them. So finding the least number that they have to multiply them by is actually not quite as nice as just multiplying the y's by each other. So in other words, if I take the first equation, equation number 4, and I multiply it by 11, and I take the second equation and I multiply it by 13, and one of them needs to be multiplied by a negative, I'll just use the second one. They'll match. I don't know what the numbers are, but they match. Does anybody have 11 times 13 memorized? What is it? No. 143. That's actually what I was thinking it might be, but definitely not one I have memorized. Okay. So the multiplication for this, we're going to have to multiply that 11 through, to multiply that 13 through. So what's 11 times 14? Negative 154y. You guys just told me it was 143 on the next one, right? Plus 143z. How about 53 times 11? Yep. Okay. It's going to simplify nicely eventually. Okay, so hold tight. The numbers are just ugly in the middle here. We're going to do the same thing with the 13s at the beginning. I'm going to get a positive, so 13 times 10, 130y. It's a little small. I have the same negative 143, though, z, here in the middle. And then I need 13 times 43. Okay, so as I wished, the z's canceled. Now I have negative 154 and positive 130. What does that give me? Yep, negative 24y. And then I have 583 minus 559. It's 24. And we all said, hallelujah, right? I mean, kind of, but yeah, because that's actually very friendly at this point. So I divide by negative 24.
We did it.
And we find out that y is equal to negative 1.
And then can we just plug that into one of the 4s or 5s?
Yeah, exactly. So now that I have this one with one of my variables found, I'll go back to either equation 4 or 5 before I multiply by the 11 or the 13, all right? And I'll plug it in to find, in this case, z.
I think we should do the second one.
You do the second one? Okay, so equation number 5. So again, I need to make things a little bit smaller. Okay, so equation number 5, I'm going to have negative 10. My y is negative 1 plus 11z equals 43. So 10 plus 11z equals 43. Subtract my 10, right? So 11z equals 33 divided by 11, and z is 3. All right. It's 2 values. Now what? I still need to find x. So I need to use one of my original equations that had x, y, and z in it, and there is definitely a choice that's the nicest choice here. Equation number 3, you bet. All right, so equation number 3 is much friendlier than the others because the coefficient, that was not what I wanted to do, the coefficient in front of x is 1. So here's my equation number 3. I've got x plus 3 times y, which is negative 1, minus 3 times z, which is 3. Positive, right? Yep. And then it equals negative 10. So I have x minus 3 minus 6 equals negative 10.
Not 6, 9.
Oh, you're right. I'm so sorry. Moving too fast. Minus 9. What's negative 3 and negative 9? So I have x minus 12 equals negative 10. If I add my 12, what will x equal? 2. X is 2. Okay? Now, that's my last piece down here at the bottom. I need to write them somehow specific. Any idea? Yeah, the ordered triple. It'll look a lot like this previous problem over here, where I have x, y, z with the parentheses and separated by commas. So, x is 2, y was negative 1, and z is 3. This is my solution. It's a lot. It's a lot. And that's why it's really important when you do this to make sure that your mind is clear and that you're being really careful. Because I'm telling you, if you lose a negative, you're going to have to backtrack, and you might have to backtrack to the very beginning.
I can see myself doing this tonight and crying because I got to the end and I got it wrong.
I understand.
I can see
Yeah,
that too.
I do understand. The Success Center might be a good place to be on Sunday night. I don't know. All right, let's try another one, okay? If we don't finish these in class today, I'll post the video for the rest of them. But I'd rather be slow and meticulous in class and make sure everybody understands what's going on, and then have you watch an extra 15 or 20-minute video or something outside. So that's how I'm gonna deal with it. The next one here, I have a lot more flexibility in my choices, but there's actually a choice here that's very, very nice.
The first one.
Which variable is the easiest to eliminate?
Oh, Z.
Z. How come?
Because they're all 1.
Because they all have the same coefficient. Some are positive, some are negative, right? So I'm going to label them equations 1, 2, and 3. Which 2 equations would you like to take first? 1 and 2. I'm actually going to work below instead of have to move it. Equation 1, which is x plus y plus z equals 6. And equation 2 is 2x minus 2y minus z equals negative 5. And this one's very friendly, of course, like you noticed, because the z's cancel out without any multiplication necessary. That happens sometimes. So if I add down, I have 3x minus y equals 1. Smaller coefficients, we like the problem better already, right? Yeah. This will now be called equation number 4. Okay, now I know I have to take equation 3 because I haven't done anything with it yet. But do I want to take equation 3 with 1 or equation 3 with 2? 1. Okay, so I'm going to rewrite equation 1 the way it was already. X plus y plus z equals 6. And then equation 3. I don't even need to multiply it. 3x plus y, because it's already minus z, equals 2.
Okay, I have a question.
Yep.
Just to like clarify something.
Sure,
So whenever you're combining, you always have to solve for the same variable, correct?
absolutely. Otherwise, you're going to find yourself stuck and not be able to move forward.
Just making sure.
Yeah, you need to get the same variable eliminated from all three equations, pairing them up two at a time, so that it pairs down to two equations now with two variables. Kenny?
When we're doing this second part, you can pick, well, I guess you have to pick the opposite.
Well, you have to pick equation 3 because we haven't done anything with it. You could choose equation 1 like we did. You could pick equation 2, but if you picked equation 2, you'll have to multiply it by a negative for the sign on the z to change and to be able to be eliminating. Yes, but it would still work. You'll still get the same answers.
So you pick whichever one you didn't do the first time,
And
and
then-
then you can use either
How
one.
I usually
Exactly.
do it is I usually go 1 and 3 and then 2 and 3 to get 4 and 5.
You can. It doesn't always work out that way nicely. It really depends on the numbers and the locations. So just have some flexibility with your choices to make sure that you're choosing things that are easiest to work with.
It just helps me remember because 1 plus 3 is 4 and 2 plus 3 is 5.
Okay,
And so that's just why I do it. 'Cause
Go for
makes me keep track of my equations because I'm like,
that'll work.
these two equal 4. So,
All right, so my z is eliminated. I have 4x. I have plus 2y. And it equals 8. There's nothing wrong with this equation, but we could actually use this equation and make it easier. Do you notice something on this equation? They're all divisible by 2. So while it's not normally something that we would just have happen and do this, because they're all divisible by 2, it might just be nice to divide everything by 2 to make the equation smaller looking. Does that make sense? So I'm going to do them and divide everything by 2. So this is now 2x plus y equals 4, and we'll call that equation number 5. So looking at equations 4 and 5, what do you notice? The y's already cancel. So equation 4 was 3x minus y equals 1. And equation 5 is 2x plus y equals 4. And sure enough, my y's in this one very nicely canceled. And 3x plus 2x is 5x, and 1 plus 4 is 5. And lovely enough, x is equal to 1. That's really nice.
Wow.
Great. Now, do you want to take equation 4 or equation 5 next?
4.
4. All right, equation 4 is 3x, and x is 1, minus y equals 1. So I have 3 minus y equals 1. You might just be able to look at that and tell me what y has to be instead of actually solving. Yeah, y's got to be 2. It's the only thing I can take away from 3 to get 1. If not, you can move it and divide and all that stuff. Okay. So y is 2. X is 1. Now we need to use either equations 1, 2, or 3 to solve for z, which is my last one. 1? Okay, I'm going to make this a little bit smaller.
Z is going to be 3.
Okay, equation number 1. So I've got x, which is 1, plus y, which is 2, plus z equals 6. So, right? Yeah, okay. And then it's 3 plus z equals 6. So what's z?
3.
Z is 3. So this one's kind of funny because the ordered pair is the ordered pair 1, 2, 3. Okay. Okay, I think we have time for one more. Yep, Divine.
So once you solve one of the variables together, you can just plug in that one number in any one of them.
Well, once you've solved, say that again, solved for one variable.
Get one of the variables.
Yeah.
and do it from
So-
to-
Once you get one of the variables, though, you want to put it back into an equation that only has two variables, which means you definitely want to use either equation 4 or 5 to do that.
The ones that we already solved.
Yeah, so it's really kind of like once you get it there, you're working backwards through your work. So you're just going one step back to find the next piece. Okay, last one for today. C, and then I'll post the video for the last two problems. The last two problems are a little weird. I will warn you of that. So question 3, I have x plus y plus z equals 9, and so forth down. We have choices again. Do you want to eliminate x, y, or z? Y is pretty nice, so we'll label them equations 1, 2, and 3. So what two equations would you like to take first? 1 and 2. So equation 1, equation 2. One is x plus y plus z equals -9. I'm sorry, 9, not -9. And then 2 is x minus y plus 2z equals 1. So just like you said, the y's add to 0. This is 2x plus 3z equals 10. That's equation 4. Equation 2 and 3. So equation 2 is x minus y plus 2z equals 1. Equation 3 is x plus y minus z equals 5. Okay, so again, y's cancel. I have 2x plus z equals 6. That's equation 5.
So we did 2 and 3?
Yes, I didn't label it, sorry. Yes, 2 and 3 is what I did. Okay, now looking at my equations 4 and 5, what do you want to eliminate? X. Either one's not too bad. X is kind of nice because the numbers already match, it's just the sign that I would need to mess with. So if I leave equation 4 as is, it's 2x plus 3z equals 10. And if I take equation 5 and I multiply it by -1, it'll change all my signs. So I have -2x minus z equals -6. Okay, so the x's add to 0. I have 2 z's, and I have 4. I'll divide by 2, and what will z equal?
2.
Z is 2. So that's my first found variable. All right, so z is 2. Do you want to use equation 4 or 5? I don't know that it really matters. 5? Okay. We'll use equation 5. So equation 5 has 2x plus z is 2 equals 6. So we'll subtract our 2. So my 2x is equal to 4. And x is 2. And then what do you want to use? 1, 2, or 3 to find y? 1? Okay. Equation 1 says x plus y plus z. So x is 2, y we don't know, and z is 2 equals 9. I bet you can just tell me by looking what's y.
No, 5, sorry.
It's 5. 2 plus 5 plus 2 is going to be equal to the 9, so y is 5. So my values, make sure you're being careful to put them in order, not the order you found them, but the order of the variables. X is 2, y is 5, and z is 2. How could we check to make sure that any of these 3 were correct? Plug them into all 3 equations and make sure they work. All right, so I'll post this video. I'll post another one where it probably says start at this time frame or whatever it is, and you'll be able to watch the rest of the last part of the lesson, okay? Have a lovely weekend, and I'll see you all on Monday. We have our last quiz on Monday over 5-1, 5-2, all right? And review for the test on Tuesday.